Further, in your professional career, if you go for any software, computer, and software applications, then you will have much more applications of matrices. See, for example, if a 2D figure is to be shown as a 3D figure like this, then we will be using matrices. You don't believe it. Similarly, for solving the linear equations in 3 variables, we make use of matrices. You know that. Now itself, you know that. That's what I have shown on right hand side. I have taken all the equations as 3 planes. If you see this diagram on right hand side, this has unique solution. 3 planes are intersecting in one point. This is a unique solution. If you see this now, it is also intersecting in a unique point, and hence it has a unique solution. But if you see this one, right hand side diagram I'm talking about, infinitely many solutions for this. Unique solution and no solution case is also there, because here no common point of intersection. That's what, no solution, right hand side extreme right, infinitely many, and unique solution. These are, I want to show you that more practically, so that if you have any inhibitions about matrices, or if you have any difficulties, particularly in understanding the concepts of matrices, it helps you out a lot. It helps you out a lot. Do you see the diagrams on the screen?
Yes, sir.
Every one of you, please respond. मैं
Yes,
तो
sir.
मैं तो बहुत मेहनत कर रहा हूँ यार आपके लिए. कैसा है कि ये सब करेक्ट करने के लिए मेरे को कम से कम 1 घंटा क्लास के लिए 3 घंटा लग रहा है यार. आपने अगर इसको यूज किया, इसका एप्लीकेशन सीख लिया, I'll be very happy, and that will be my ultimate goal, to make you understand all this. So what is that given on right hand side is purely about the consistency and inconsistency of the system of linear equations in 3 variables. If it is 2 variables, you know that in your lower classes itself we have learnt it. What is that? 2 variables linear equations means they are nothing but straight lines. Everyone knows. 2 straight lines may be intersecting each other, may be parallel to each other, maybe coinciding with each other. How do we decide that? A1 by A2 not equal to B1 by B2. Then we say that the lines intersect each other, and hence it will have unique solution. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Then the lines will coincide with each other. Lines will coincide with each other, and thereby you'll have many solutions. If A1 by A2 is equal to B1 by B2 but not equal to C1 by C2, lines are parallel to each other. Lines are parallel to each other means how many solutions do you have? No solution. So what I did, I have collected those, of course, they're all collected from internet only. Nowadays, Google provides everything, whatnot, everything it provides. But according to my requirement, I have collected all of that. So what happens in matrices, 3 by 3 matrices, what happens? These lines will be now taken as planes, because these are system of linear equations in 3 variables. System of linear equations in 3 variables. A1x plus B1y plus C1z is equal to D1. A2x plus B2y plus C2z is equal to D2. A3x plus B3y plus C3z is equal to D3. If you have 3 planes, you know how the 3 planes will be? It can be understood very comfortably in the room in which you are sitting. In the room in which you are sitting. If you see the floor on which you are sitting, are you sitting or sleeping? or lying. Lying means both. Lying means Lying or lying LIE. Dhananjay, are you lying on the floor? Are you sleeping or sitting? ठीक है, धनंजय गुस्सा आएगा बार बार उसका नाम लेने से, और वो सुन रहा है नहीं सुन रहा है?
सुन रहा हूँ सर।
सुन रहा है, गुड बॉय। श्रीवर्धन, देवश्याम, पुष्किन, विश्मा, अंश, जश, आर्यन, जीत, प्रथम,
Yes, sir.
कीर्तन,
Yes, sir.
वेदांत,
Yes, sir.
जहान,
Yes, sir.
हीत,
Yes, sir.
जहान, ऐसा बोलने से मेरे को ऐसा लगता है, जहान बोला तो वो तो ऐसा सो रहा था तो उठ के यस सर बोलता है, मतलब बहुत रिलैक्स्ड है वो। ठीक है, मैं क्या बोल रहा था बेटा, ये सब का एक डायग्राम देख के आप बता सकते हैं बेटा? कोई बताएंगे राइट साइड पे कितना सॉल्यूशन है? डायग्राम तुरंत बोल रहे हैं आप, तुरंत। सब अनम्यूट हो जाओ, सब अनम्यूट हो जाओ। इधर कितना है बेटा? और ये तो आंसर है उधर ये तो इनफाइनाइट, वन सॉल्यूशन, नो सॉल्यूशन, देख के बता सकते हैं। पैरेलल प्लेन्स हो जाता है, इधर भी यूनिक सॉल्यूशन, no solution, infinity many solutions, like that, like that. The system of linear equations can be comfortably understood through three-dimensional geometry. That's what I mean to say. Through three-dimensional geometry, you can comfortably understood all this. Similarly, how the beautiful applications of matrices is there in the day-to-day life, or real life applications. We call them as real life applications. This is a matrices, this is a circuit. You can see that. Similarly, this is related to the chemistry, minimum energy state. ये सब matrices में कैसा represent करते हैं? That's what I mean to say. That's what I mean to say. So I have collected all this, and there is a that really because to create interest in you, I have seen the applications really myself. I surprised what I'm saying really now. Never so far I have seen these many applications. Really, financial portfolio, that is shallow water models. How is it done? Through matrices. Through matrices. Yes, there are applications. I have gone through that. MRI models. MRI is in medical applications. MRI models and all this they use. Similarly, analog circuit models. Okay. Similarly, you will have in gaming applications also you have more and more gaming applications. And if you see in data, in matrix, in data management, Google, if you Google it, how many times it appears? This, you see ESPN, TED, and all this. In electrical circuits, the formation, just see. Formation is, just see, it is in the form of the matrix. Weather forecast, or in the advanced level, all these are using matrices only. Antenna arrays model, just to see the perfect shape of this. And similarly, neural networks. And there is a explanation for all this. There is explanation. Matrices in robotics. robotics. They are to be moved in a systematic way. Useful to define more than one. Just what happens now, very importantly, because you're all interested in computers, computer accepts only 0 and 1 binary code. So what they do now, for black they give 0 and for other color they give 1. Then the matrix is formed 0, 1, 1, 0. And if you want to see the shape, some shape is to be formed, then that will be formed as a matrix. Just see the smaller parts of the diagram there. This is black 0 and other colors they will define for 255 different colors they will define, and with the mixing of those 255 only different colors will be formed. And if you want, see this one you might have seen grayscale. These are all formed using matrices only. These are all formed using matrices only. Similarly, if you see the grayscale, the color combinations, just see how many colors they define. 0 to 255. There are 256 shades are there. And a negative side of black and positive side of black, they will define the numbers, and like that it is formed. All these are made up of matrices only. All these are made up of matrices only. See, these dots also, according, they will define the colors with the matrix form. Okay. And here also, just to see different shades. Nowadays, we are making use of mobiles to see the diagrams. And even in the mobile, if you want to rotate the diagram, then see the diagram here. What is that they do now? The input, and they will find out the transpose of it. The input is given as a matrix, as a diagram, and if you find out the transpose of that matrix, the diagram will be rotated 180 degrees. The diagram will be rotated 180 degrees. So whatever the diagrams, if you are seeing in the straight manner, if you want to see that in the horizontally, then that application is nothing but matrices only. That application is nothing but matrices only. Similarly, the 3 players playing football here, then how many times they are hitting the ball, then that will be shown with the first player, second player, third player, 0, 1, 1, 0, 0, 2, 1, 1, 0, like that they are mentioned. Even in to make the three-dimensional diagrams in games also that is used. Who is that boy? Anyone tell me that? Because you play the games.
Okay.
Okay. I have collected all this just to create interest in you about the matrices and its applications further. So whatever you learn here in 11th and 12th, they have very good number of applications in your future studies. Okay, let me now go through the questions. But before that, let me understand when this topic was over, how many months back or how many days back? I want to know that. At least approximately.
Last year, November.
Yes, sir, 2019.
फिर से बता.
November last year. Before we started derivative.
So November last year.
सर कुछ याद नहीं है बराबर.
तो फिर से नवंबर आ गया. 2019 रिप्लाई दिया है प्रथमेश ने. उसका माइक नहीं है यार, लेकिन टाइपिंग तो जोर से करता है वो. ठीक है. या तो totally the concepts are to be revised thoroughly then, isn't it? Every concept is to be revised then, because long back you have learnt it. Okay. Let us start with the determinant. And in the determinant, the row and column operations, it is a 4 by 4 matrix given in the beginning. 4 by 4 matrix given in the beginning. So 4 by 4 matrix, if you want to find out the determinant, then you have to express it as a 3 by 3. 3 by 3. So let us try to make these zeros. Let us try to make these zeros if possible. It is given to be 0, and you have to answer the questions like this. Options: A, B, C are in AP, B, A, C are in AP, C, A, C, B are in GP, A, C, B are in HP, like that. Okay. Now, anyone do tell me how to make this 0 A plus C? Here AC is there. Let us try that. A plus C, and you subtract A and C.
Subtract C.
B plus C, subtract B and C. A minus C, minus A is there, and plus C is there. That means you will get it done. You will get it done. And finally, here also you will get X plus Y getting cancelled. So, what is the operation to be written here? It is what I'm writing: C4 changes to C4 minus C1 minus C2. Okay. Let us do that. Come on, anyone, do you help me, please? I'm begging for help, but no one is helping me yet. Huh? Sab log
0, 0, 0 and 1 in the last column.
A, C, A minus B, or X either C, B, and B minus C, Y, and C minus A, B minus C, 0, Z, and this is A plus C minus is 0. This is what we want. B plus C minus B, 0. A minus C minus A getting cancelled. Minus plus B minus B getting cancelled. So minus C and minus of minus C plus C, that becomes 0. Correct or not? Now what about the last term here? 1 plus x 1 you will have. You will have 1 there. Okay. So we got it comfortably. We have got it comfortably. And this is a 3 by 3 determinant. Now it is expressed as a 3 by 3 determinant. By making these 3 zeros, you can expand this determinant through the 4th column. You can expand this determinant through the 4th column, isn't it? And is there any other possibility to get more zeros? Just check it out, please. Just check it out. Is there any other possibility to get more zeros? Are you there, everyone? I asked a question, yeah. I asked a question. Here, I think
we can add C1 plus C2 to C3.
C1 plus C2 to C3 means C minus A plus A minus C. C minus A plus A minus C. See, let us write that. Let us apply. You mean to say, Dhananjay, C3 we have to change, C3
Yes,
changes to C3 minus, plus C2 minus A plus A, and minus, C1, just a moment. C3 plus C1 minus C2. Is it you're saying?
Yes, sir.
Let us see that. So that you can get the answer directly. So what is that you get? A, C, A minus B, X remains the same. C, B, and B minus C, Y remains the same. Now C minus A plus A minus C, 0. Good. Similarly, B minus C plus C minus B, 0. Oh, you're getting more zeros here now. Similarly, 0 minus A, 0 plus A minus B. Uh, anyone, do you tell me this element here? Anyone, please? 0 minus A, 0 plus A minus B.
A
A
minus
minus
2B
B minus
plus C.
A minus 2B plus C, na?
Yes.
Yeah. And next one. Z plus X.
Plus X minus.
Baki sab as it is. Now I think it is done. 0, 0, 1.
A and C is the answer.
I think it should be A and
C.
C, na? Yeah. It is comfortable now because two more zeros are there. Just how do you say this matrix, Just given with a good technique here. Problem is good. See, how do you say this? This determinant is to be find out. I'm showing it separately. So 4 by 4 reduced to 3 by 3. Again 3 by 3 reduced to 2 by 2. Just check it out. Correct or not?
Yes.
Let's see. 2 by 2. Are you there, everyone? What I'm marking there? Do you understand what I'm marking there? 4 by 4 matrix taken, reduced to 3 by 3 determinant by making the other 3 zeros here, and this is 1. And after that, in the second operation, what we did is 3 by 3 is again expressed as a 2 by 2 determinant, so that you'll get 2 zeros here. And if you get 2 zeros, you can write the answer now directly. Anyone? Do tell me the determinant now. A minus 2B plus C into AB minus C squared. Done, please. To solve the question itself, it has taken that much time. So to form the question, how much time the professor takes, just imagine. You must appreciate the professor for forming this type of question, because he has to do reverse engineering for this one. Reverse engineering. He wants to make these two the answers. Then what he has to do, he has to make reverse engineering in such a way that this matrix is formed with the determinant. Okay, how much difficult it is. It should be really appreciable. And in the determinants, the row column operations is very, very important. I think you need not have to by heart them. That is the reason why everyone must be remembering this row column operations, isn't it? What I'm saying is correct or not?
Yes, sir.
Yes, sir.
Okay. So,
Sir,
yeah.
sir,
Srivardhan.
can you do this sum with putting XYZ as equal to 0?
He did not say anything about XYZ, no? Yeah.
So they are
You
independent.
can do because finally.
So they are independent of X, Y, Z. They will be independent of X, Y, and Z.
You can do Srivardan, no problem. You can do, because the answer is not containing XYZ there. You must get that idea. Answer is not containing XYZ. You can follow that. So what is the final answer here? It is option A. A, B, C are in AP according to this, and A, B, C are in AP according to this, and AB is equal to C square we have got. So A, C, B are in GP. C. So option A and C. Okay. Everyone, is it comfortable? And just remember the row column operations of matrices. Okay. So I'm closing the session for today, and we'll be continuing with more and more problems in the next session. Okay. See you all, beta, in the next session. Bye bye, all of you. Have a good day.